Question 1a. So 5/6 times 2/7, dead easy this one. I multiply across the numerators, which is the number on top, to get 5 times 2, which is 10. And across the denominators, 6 times 7 is 42. Now I'm not going to simplify this one because we're just looking at the skill of multiplying and dividing fractions, but just know that you could simplify that one. For part B then, 2/15 divided by 3/5. Well, I could write this sum in a slightly different way. I could still call it 2/15, but it's the same as multiplying by the reciprocal, which basically means that I'm going to take this fraction and flip it upside down. So 2 times 5 gives me 10 as my new numerator, and 15 times 3, 45. Same again, I'm not going to simplify this one. 1b. So over here I've got 4 times 3, which is going to give me 12 on the top, and 5 times 8, which is going to give me 40. Over on part B, it's 3/12, but I'm going to write this as a multiplication, and the second fraction is flipped upside down. So 3 times 3 is 9, and 12 times 2 is 24. 2a. So the number 300 is a product of its prime factors. I can split it up into 30 and 10. That's a pair of just normal factors. Neither of them is prime. The 10 I can split up into a 5 and into a 2. Now 5 is prime and 2 is prime, so I circle them both and I stop there. The 30 I can split up into 5 times 6. 5 is prime, so I circle it, and 6 isn't. And the 6 I would break up into a 3 and a 2. Both of those are prime. So as a product of its prime factors, 300 is 2 squared, because there's 2 of them, times by 3 times by 5 squared. 2b. Same as the previous one here, so 420, I'm going to split it up into 42 times by 10. Now you may have split up 420 in a different way, but we should end up with the same prime factors. So 10 is 5 and 2, both of which are prime, so I circle it. 42 is made up of 6 times 7. 7 is prime, so I circle it. And 6 is made by 3 times 2, both of which are prime, so I circle them. So 420 as a product of its prime factors is 2 squared times 3 times 5 times 7. 3a. To solve this one, I'm going to need to subtract 7 from both sides. That's going to give me 4x equals 32, and then divide both sides by 4, giving me x equals 8. Over on this side, I'm going to need to add 5 to both sides, so that's going to give me 9x equals 36. Divide both sides by 9, x equals 4. 3b. On this one, I need to subtract 2 from both sides, so that gives me 9x equals 9. Divide both sides by 9, x equals 1. And for part B, I'm going to need to add 5 to both sides. That's going to give me 4x equals 10. And divide both sides by 4. Two different ways of writing your answer for this one. You could leave it as the fraction 10 over 4, or you could have written down 2.5. 4a. So to measure the size of this angle, I'm going to need a protractor. Make sure that it's lined up with where the angle starts from, where those two lines meet. And there's two scales I could use. I'm either going to use the scale that goes 180 and counts down, or starts at 0 and counts up. I'm going to need to use the scale that starts at 0 and counts up. So I measure very carefully, and I can see that that gives me an angle of 117 degrees. 4b. Same again on this one. Protractor is going to go on. I look at my two scales, and I always want the scale that starts at 0 and opens up just the same way the angle opens up. So I'm going to use the inside version of the scale, and if I read very carefully where it marks off, I get that as 57 degrees. 5a. So a pair of parallel lines are two lines with the same gradient which will never meet, and there's one, and there's the other one to make the pair. Perpendicular lines meet at 90 degrees, which you can see I've marked on the diagram using a P. 5b. So my parallel lines in this one are the top line and the bottom line, and actually in this one there is no perpendicular line, so I haven't added those on. 6a. So to expand this first one, I'm going to need to take everything inside the bracket and multiply it by 4, the number outside the bracket, and that will give me 4x plus 8. Second one, I'm going to take everything inside and times it by x. That's going to give me x squared minus 5x. And on the bottom one, I've got to multiply everything inside the bracket by not just 2, but y also. So that's going to give me 6y squared plus 8y. 6b. Same again on this one. I'm going to do 7 times everything inside the bracket, which is going to give me 7a plus 7. Then m times everything inside the bracket, so I'm going to get 2m minus m squared. And on the bottom one, I'm going to end up with 10t squared plus 5t. Question 7a. So to find the nth term of this sequence, I need to see what the difference is between each of the terms, and I can see that it's 3 in each case. So this is based on the 3 times table or the 3n sequence. As a little cheat, what I can do is count the sequence back one space and see what would go here, and it would be the number positive 1. So I'm going to add that onto the end, and the nth term of my sequence is 3n plus 1. To see whether 155 is in the sequence, I'm going to take my nth term and make it equal to 155. Now if this solves and gives me an integer value, then I know that 155 is in the sequence. So solving this equation, I can see that n ends up as being, well, to do this one without a calculator, what I would do is I would ask myself, is 150 divisible by 3, which it is. 50 times 3 is 150. So using that idea and the fact that it's got to count up in threes, 150 is divisible by 3. 153 would be divisible by 3, 156 would be divisible by 3, but not 154. It actually ends up as being 51.3 recurring. So the answer here would be no, it's not in the sequence. Question 7b. Same as before on this one, I'm going to see what my sequence goes up in, and I can see it goes up in 4s every single time. So it's based on the 4n sequence. And if I was to count back one space following on the pattern, I would get the positive 5. So this sequence is 4n plus 5. Same as before, to see if 88 is in the sequence, I'm going to do 4n plus 5 equals 88 and solve this equation. And 83 is not divisible by 4. It actually ends up as giving me 20.75. So the answer here is no, again, not in the sequence. Question 8a. 3 squared is 9, square root of 64 is 8, and to estimate the answer to root 14, well, I know that the square root of 9 is 3, and I know that the square root of 16 is 4, so my answer is somewhere in between 3 and 4. It's obviously a lot closer to 4 than it is to 3, so my estimate on this one is going to be around about 3.7-ish. Question 8b. 10 squared is 100. The square root of 25 is 5, and to work out the square root of 52, well, I know that the square root of 49 is 7, and I know that the square root of 64 is 8, so the answer is somewhere in between there. It's closer to 7 than it is to 8, so I'm going to estimate around about 7.2. Question 9a. Alan is X years old, his brother is 5 years older than him. So if Alan is X and his brother is 5 more than that, my expression is going to be X plus 5. Alan's dad is 3 times as big as he is, or as old as he is in this question, so this time I need to take my X and multiply it by 3. So my expression is 3X. Question 9b. Betty's hair is Y centimeters long. Carla has hair that is 3 centimeters shorter than Betty's. So Betty's hair is Y and Carla's is 3 less. So my expression is Y minus 3. Daisy has hair half as short as her. So if you take Betty's hair, which is Y, and divide it by 2, that will give you the length of Daisy's hair. Question 10a. So to work out the area of this parallelogram, first thing I need to know is that this number here is not important at all. I need the base of the parallelogram multiplied by the height, so 8 times 4, which is 32 meters squared. Question 10b. Same again, I'm not interested in the 7, it's just there to try and confuse me. I need to do the base, which is 9, multiplied by the height of this, which is 6, and the area of the parallelogram is 54 centimeters squared. Well done if you got all of those questions correct. Don't forget to watch tomorrow for Foundation Pack number 8.